Hey everyone, Chris Mattson here. In this video, I'm going to show you how I solved the Mars rover wheel problem for the fluency test. Keep in mind that there are many ways to solve these problems. I'm just showing you how I would approach it. Let's do it. First thing I'm going to do right now is I'm looking at the drawings. I'm going to get a strategy together, and I'm going to show you a little bit about how that strategy is going to be. All right. Okay, what are we going to do? First thing I'm going to do is I am going to do the hub, and then I'm going to do the spoke, and then I'm going to do the tread. That's sort of the approach I'm going to take. I'm just going to build out from the provided part, which is the shaft. So I have downloaded the parts, and in the shaft, what I'm going to do, I need to make my hub fit exactly inside of this portion, into this portion of the shaft. And so I am going to go in here and do some master modeling. I'm going to start a new assembly with this part, and then I am going to create a new part in that assembly where I'm going to go get all of these surfaces that are in here. And then what I'm going to do is also while I'm there, perhaps instead of getting this surface right here, I'm going to get an offset version of that surface, because this drawing right here shows us that we're offset by 1/4 of an inch. And then I'm likely to do the same thing right here, take this plane offset 60 thousandths of an inch, which is what we see right there. Then once I get that piece, I'll turn that into a solid, and then I'll just create this whole portion with a solid revolve, probably like this. Cross section, revolve it around that center axis. Then I will go and add the chamfers and fillets and other stuff at the end. And I'll have to add these things in. I'll add one of them and then pattern it around. All right, now I'm going to show you what my shaft strategy is going to be. For the shaft strategy, I am going to, let me just think about this for a second. A critical point in this shaft strategy is this point, which is the center of the wheel, but is also the center of these arcs that are here. And so I'm probably going to come in on my top plane and orient my planes in this area. And then I'm going to create a construction line, probably create another construction line. And then this is going to help me a lot, actually. Then I have to turn my attention to this view down in this area. And in this view, I am going to essentially have to recognize here that I've got some key planes that I need to think about. The plane that this foot is on down here, the plane right above it, this plane that's over here, this plane that's right here, and this plane that's way over here. In essence, what's going to happen is I'm going to loft to the first one, then I'm going to sweep around to the other one. Then from here, I could create a sweep or an extrude upward, and create that part, and then this part here is going to be a loft that I do from this cross-section to this cross-section, and then make these faces all tangent to each other. Another key part of this strategy is getting those spots where I'm going to draw those sketches. So here's basically where my top plane is. I need to have another plane that's down 1/4 of an inch, and then I probably need to have another plane still that's 1.15 inches down below that one. So that's what I'm going to do. So I'm basically going to draw all these cross sections. The one cross section, which is right there, and then sweep it over like that. This cross section, which is down there at the bottom, and then loft up between those. And then I think I'm just going to create this whole thing right here with an extrude upward in the same direction that I'm looking at right there. And then I'm going to loft in that area. And that's what I'm going to do for my shaft. Excuse me, not my shaft. What is that called? The spoke. All right, now I'm going to show you my strategy for the wheel, for the, what do you call this? The tread. Pretty much what I'm going to do here is I'm going to create a revolve where I basically draw this cross section and revolve it around. That will give me my base product. And I can go get all of these shapes right over here for that. Okay, then I can revolve that around. I'm not going to put on any of the fillets or anything yet. I'll wait to the end to do that. It's a little bit cleaner so that I don't get fillet lines confusing my sketches or anything. All right, then what I'm going to do is, because this portion right here, let me draw this in another color. Because this portion right here is also arced or curved, it looks to be like an offset from this face. I'm actually just going to do that. I'm going to take the absolute outside face of the tread and I'm going to offset it with a surface in that direction, however much that I need to, which I think is about 1/2 inch. Yeah, I can tell from that 1/2 inch. Then what I'm going to do is I'm going to attempt to create a plane. Let's see, how am I going to do that? I'm going to create a plane somewhere in here, right in between the new surface and the existing face. And then I am going to draw this profile and then extrude in that direction up to surface and extrude in this direction up to surface. And that will get me the shape that I want. And then I'll add some fillets and some chamfers and do some other stuff, and that will be that. Okay, time to do it. Done with the strategy. Let's set that aside. I'm going to open up the engineering drawings on this other computer. This will, this is what I'm going to be referring to when I'm looking in this direction. All right, so the first part that I'm going to do is the hub. The hub is going to be built off of the shaft that was provided using master modeling techniques. So I've opened up the supplied shaft, and I'm going to now use this part to create a new assembly. This is how we do the master modeling technique. And the new part is being popped in there, and there it is. We're going to switch this to IPS. We're going to come in here and save this. And we are going to call this Mars Rover Wheel Assembly. Save. And then in here, I'm going to create a new part. So I'm going to insert a component, a brand new part. It wants me to have a name for this, which is going to be called Hub. It wants me to place this now somewhere. You can see that in the bottom left-hand corner of the screen. It's telling me what to do. That's now been placed in there. And I'm going to switch this to IPS. And I'm just going to save this entire thing just to make sure everything is copacetic, so to speak, and aligned well. Now I'm going to come in here into my hub, and I'm going to edit the hub in place. Let me look at this for a second here. I think what I want to do is slice this so that it will be like slightly easier. I'm not sure if this will work, but I'm gonna try this for a second. This might make it extra easy for me to go in and pick this stuff that's deep inside there. Okay. Yeah, I'm gonna try this. I'm gonna get all these surfaces to be copied. I'm going to copy them over, and I'm going to copy them over with a surface and using an offset. And I'm going to set my offset to 0. And setting my offset to 0, I'm just going to come in here and start picking all these. And I can see that it's going to show me the surface way up there, which may cause a little bit of trouble for reaching into some of these. But I think that'll be a little bit easier. The hardest ones to get actually are these little things. Maybe if I get those first, for each one of those, that will go slightly smoother. Okay, and I do need these down here. All these surfaces are being brought over to the master model. They're going to become part of the new part. I'm going to make sure I don't forget any of these or miss any of these. Otherwise, I'm going to have a gap in my part, which I don't want to have. I can get that one and that one. This one, this one. I'm sure there's an easier way to select these. I don't know what it is. I don't think I'm going to, I don't think it's going to kill me to just pick these. Okay, go get those little ones because they're the hardest ones to get. It's annoying, of course, to have to pick all these, but I do want to make sure I'm in control of which surfaces I'm picking. This is an important, super important part of this process. So it's annoying, but it's easy and important. Easy and important is not a bad thing to focus on right this second. Okay. Excellent. Just keep going around until they've been all selected. Now it's starting to get a little bit more annoying because one side's kind of, ooh, look, one more left, yay. I'm sort of overlapping, one side's starting to come into my view. Okay, well, I think I got all of those. What I want to do now is make sure I get this one, which we hadn't gotten yet. I think those are all my surfaces. I'm going to hit yes on this. Then I'm going to come in here and just hide this one for a moment. You can see where I forgot. Okay, look, I did forget one. That's right there. See if I forgot any of the fillets. I'm looking around. Did I forget this one in here? Nope. All right, somehow I forgot that thing though. Let's go put on these planes, see if we can orient ourselves as to where we are. We're the one that is, right near that top plane. So, just gonna come in here. I turn this on. So this is the one that I need right here. In this offset surface, I'm going to edit this. I'm going to add one more to this. Okay, gonna add that thing. And let's see if that did it. Okay. Good, I'm gonna go with that for now. I'll turn this off. Okay, that operation seemed to have worked. Now, I don't have the bottom, but that's okay. I don't have the bottom because the bottom is not going to be a 0 offset. It's going to be a different offset. According to the drawing, it's going to be offset by 1/4 of an inch. So I want to offset surface 0.25 instead of 0. And that one looks like it's come the right direction. That's one thing that I want. And then this surface right here, not sure exactly if this is how I want to do it, but I'm going to try this. Create another offset of this one, and we're going to be 60 thousandths of an inch. That's what the drawing says. Yep. Okay. I'm going to come in here and hide this for a second just to see how we're doing. Okay, good. Now we have this gap in here that needs to get filled, and that needs to be done, but we're gonna do that in the actual part. So we're gonna save this, get in here. This is how we use our master modeling technique. I think we're about 10 minutes into this model now. Save as, just gonna save that thing. And I'm gonna come open up the hub in its own file. And now I have the task of having to fill in this gap. And I'm not entirely sure how to do that. Let's see. Hide these. I think the best thing for me to do is to extend up to surface. And I want to extend up to this surface. That's interesting. Why didn't go all the way up? Oh, it did. Okay. Yeah, so I'm going to grab these edges. Excellent. Again, slightly annoying that I got to pick all these edges, but not hard to do and important to do. Now, unfortunately, I think we may still have another annoying thing to do to fill in that gap. You know, mostly I offset this 60 thousandths of an inch because I want to make sure I get the offset right, not because I actually wanted to use that surface. But now that I have that surface there, maybe I should, oops, I do not want that face. Delete that face. Whew. Glad I didn't delete them all. That would have been, if I said clear selections, everything would have been gone. That would have been super bad. Not that bad, just annoying. That's okay. This is part of the process, is to be able to specify what I want. Okay, I don't want that face. I'm going to delete that. I just want the edge. I'm trying to extend just the edge. Okay, keep going, keep going. An exercise in endurance. Patience. Of course, when you're doing this not being terribly experienced, you might be spending all your time doing these clicks and at the same time wondering if you're doing the right thing. You know, sometimes I wonder if I'm doing the right thing. That looks like I got all those. Let's take that. See what that looks like. It's thinking. Okay, see, I can rotate around this way and see what kind of gaps I got. Okay, that was useful. I think the thing that I'm going to do now is I'm going to take this offset number 3. Is that this one? And I'm going to hide this. Yeah, I'm going to hide that. Actually, let me unhide that for a minute. I'm going to grab this surface. How do I want to do this? I'm going to grab this surface, and I'm going to create a plane right through that surface. Not offset to it. I want it to be coincident with that surface. Okay, and then on this plane, I'm going to just draw a giant planar surface. This may or may not be a good idea, or this may or may not be the most efficient way to do it, but frankly, I think this will work fine. Okay, this is a sketch that I'm making. I need to go orient this in space. Okay, let's get the center of this. Let's get this. Make it coincident. Let's find the center of this, the center of this, and make it coincident. Let's make this side equal to this side. Let's get a dimension on one of these. This can be just some giant dimension like 10. All right, now what I want to do is take this sketch and create a planar surface in that sketch, which I just did. Yeah, excellent. So now what I want to do is some trimming. I want to use, okay, trim. First of all, let's trim off this bottom side. Okay, we get rid of that one. Okay, we don't want that anymore. Let's get rid of these planes because they're sort of not so cool to look at. Can I pick all of that? Okay, let's trim. Yeah, then we want to remove this. Yeah, perfect. Then we want to come in here to this offset and hide that. That's what I was trying to hide to begin with. Okay, now I want these. I want all of this to become one solid now. Right now, it's not a solid. I want it to be a solid. So I'm going to knit these together. Let's make sure it didn't take offset 3. Yeah, good. Okay, offset 3 is the one we have hidden. Okay, merge entities, create solid. Let's see if this works. Great, let's slice it in half, see if that worked. Excellent. That's what we want. Turn this thing off. Let's come back in here and get some these planes turned on. Let's create a reference axis between this and between this, because I'm going to now make a revolve. And it will help if I have an axis that I'm going to deal with. I can make that a little longer if I want to. Great. And so what I'm going to do is come in here, sketch on this plane. Be normal to that. Excellent. What I'm going to have is some sort of... I gotta check the drawing here. Okay, I guess I have some sort of thing that looks like this. Okay, now I just have to get some dimensions on this. This thing is 0.5. This thing right here is 3.1. It's 6.2 divided by 2. And then I got this one. I need to save this thing. This one's 3.6. Okay. It says I'm fully defined. So we're going to accept that. I'm going to save this before something bad happens. I'm going to take sketch 3 and do a regular revolve. This is a solid revolve, 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 revolve. That's it. I can get my axis of revolution, which is that one. Okay, then looking at the drawing, I have a chamfer to put on, and I have some fillets to put on. All right, let's get rid of these. Okay, fillet. Let's do a fillet first. We have a fillet on this edge, which is that value. It says 0.1. I also have the same value on this one. I maybe would have done these in two separate operations, but since I'm just trying to create what's in the drawing and they are shown to be the same exact thing, we're going to take that. Same exact dimension. I'm going to take that. Okay, and then we have a chamfer that's back on this side. Chamfer. And this chamfer is also 0.1. Okay, now I'm just going to do a quick check just to make sure things are looking okay. Measure, measure, measure. From here to here should be 250 thousandths. Yeah, right there, delta x, 250 thousandths. And my x direction down here is being shown correctly. So clear that. And then from here to here should be 4.31. Great, and it is 4.31. So that is worked out just right. We have a little bit of work to do on the front, and then we have some material specification that we got to do. I might as well do the material right now. Okay, material, we're not steel, we are titanium, and we are going to be commercially pure titanium R. Yeah, it's this one. Apply close. Okay, great. Now let's come in here. Almost done with this first part. Okay, we have plane 1 and we have right plane. Okay, actually, I don't want to look at this one right now. Whoops. What I want to do is create a new sketch on this face. Okay, and then according to this, I need to create something that looks like this. All right, here, this thing. Oops. Using geometric relations, get everything sort of right in position to where we want it to be. Okay, what else is this asking for? Okay, so this dimension is 0.75. And then from here to here is 0.93. Okay, let's make this one and this one equal to each other. Okay, that doesn't necessarily make the angles equal to each other. Okay, then I need the center of this to be lined up with this. Then those will make, that's interesting. Okay, and then I got one other thing, which is this dimension from here to here equal to 130. 1.3, I mean. Okay. And then my problem actually is that I need the center of this, wherever this arc is. Okay, look, I don't know why that did not take that relationship before. This point and this plane should be coincident. There we go. Then I have got to get one more dimension on here, and that's this one. And this one is going to be 3. I don't know what just happened there. 3. Oh yeah, we actually have one other dimension as well, which is from here to here. This might not like this. Okay, there we go. Okay, so 0.93, 7.5, 3, 1.3. Everything's all nice and centered and symmetrical. Great. Now we're going to take this and we are going to do an extruded cut down 50 thousandths of an inch. Let's see if we went the right direction. Yes, we did. Perfect. Now we're going to take this thing and we are going to circular pattern it. And we are going to make 6 of these. And our direction is here. Okay, so this is our save. Let's save this thing. Let's do a little check here on our mass properties. 6.75 pounds. Okay, 6.75 pounds is not what we see in the weight on the drawing, but the note for the drawing in note 4 says this is the weight for the different configuration. So let's save this thing. Did we save it a minute ago? I think we did. Go back into our assembly. And in our assembly now, we can go ahead and unhide this one. We want to take this and switch this to a 3.5 configuration. And hope we don't get any errors. Let's actually see how that worked. It's interesting. At least it changed sizes. Now we're going to save this. Save. And we're going to hop back over to our other part, which is the hub. Let's open the hub. And now let's do our mass properties. 10.27. 10.27, and here we got 10.29. So I'm just going to go with that as being okay right now. Great. That means we're basically in line. Let's get our decal in here while we're here. Okay, so we're going to go over to Render Tools. We're going to go into Edit Decal. In Decal now, we're going to tell it where the decal is. Decal is going to be in here. Let's see, Mars Rover wheel. There's our decal. I'm going to choose a surface for it. That one. I'm going to use the image alpha channel. I'm now going to map. And let's see, I want to rotate this 270 degrees. And then I want, okay, my mapping, size and orientation. I want the height of this to be 0.9. Great. That's it, right there. There's my part, saved. Actually, according to the instructions, I have got to get some screenshots. The screenshots will require me to do something here, which is I need to create a exploded view. How do I do that? Exploded view, new exploded view. Here we go. Pick a component. Let's pick this one. Pull it out. Say good. Okay, there's one screenshot. What do? We go back over to our, let's actually save this thing. Save into our assembly. Let's go here and get our 3 configuration, and it should get smaller. Ooh, that's interesting. Did that update? Let's hit the rebuild on this. Let's check this measure. This diameter is 3.5. This diameter is 3. Okay, we got a problem here. Why did that happen? Why did that happen? Let's save it. And rebuild. Let's try going to the other one, 2.5. Okay, that one looks like it changed. Let's check let's measure this. Let's clear this. Measure this diameter. It's 2.5. Clear. This diameter is 2.5. Excellent, so that one worked. I don't know why the other one didn't work, so there would be another one of our screenshots. So we'd have our screenshots for 3.5 and 2.5, but we did not get 3 to work right. We're going to check that right now. Might have been some sort of graphical thing. Might have been that it was sort of stuck, not knowing what to do. Okay, look, that updated. Let's go ahead and check these. Measure this. This one measures at, that doesn't seem to measure. This one, measure. This one's a diameter of 3. That's great. And this one is a diameter of 3. So we would take this as our third screenshot, and we'd be done with that. Okay, done with that piece. We're going to save all these. Now it's time for us to move on to the spoke. All right, so relative to the spoke strategy, let's try to make sure we do a good job on that. We're going to create a new part, and our new part we're going to save as a spoke. Going to switch this to IPS. We're going to go get our material. What material do we need for this? We need that same commercially pure titanium. So that one's there. I think we were about 30 minutes on the hub. Okay, so now we're in here, and to follow our strategy, we're going to come onto our top plane, and we're going to put the center of the wheel right in here. So that means that I'm going to have, okay, that didn't work. I'm going to have 2 circles. These are defining the arc that is 8.7 and 9.6 on the radius, right? Okay, look, let's not even dimension this yet. Let's go in here and get some more stuff. Here's going to be a construction line. And here's going to be another construction line that's out here. And then I'm going to have another line that's over here. I know this looks sort of funny, but let's figure out what's going on with this. This one's going to be a construction line. This one's going to be a construction line. Frankly, all of these are going to be construction lines. Can I do more than one at a time? Yes. All right, now I'm going to smart dimension some of this. This thing right here needs to be 2 inches away. And this need to be 15 degrees apart from each other. And this other one. Okay, this and this need to be 45 degrees away from each other. And let's go in here and trim some of this because we don't need these. That's not working. Trim. Okay. Then we want the center of this. I'm just kind of cleaning up all of my stuff here to be coincident. We want this one to be a certain size, which is 0.75. All right. And then we want this to be a certain dimension. In terms of radius, that one is going to be 9.6 in terms of radius. And this one is going to be 8.7. Great. So that worked nicely. Let's pull these out further. Okay, so this is what I need. Great. So that's one sketch. That sketch is going to be quite helpful for me. Now going to create another sketch on here, and I'm going to make my first cross section, which is going to be cross section BB. Okay, and the way that that's going to work, the first thing I'm going to do is I'm going to go take this and get that part. And then I have that same geometry that was kind of existing on the, I guess I got this one, and then I've got this one, and then I've got an arc between these. Whoops, that didn't work. All right, now I could take the center and put it on here if I want. Before I took the middle point, I want this thing and this thing to be equal to each other. And I want this dimension from here to here to be 0.93. Actually, okay, I'm doing the wrong one here. This is not what I want. I need to be doing section BB, not section CC. So I want this to be 0.6. Okay, and then I want to take this and delete it because I don't want it. And then I want to take a line from here to here. And then I want to dimension this line. And that line needs to be 1.1. And then from here to here needs to be 0.6. And I'm fully defined on that. Okay, great. So that is the first part of section BB. I'm going to take it and sweep it over to here, but I've got to get a guide path for that, which I'm going to make right here on this front plane. Okay, so I need a 3-point arc from here to somewhere else. That's not working. From right around here to some other point. I don't know exactly where it is. Okay. Now I want the center of this circle to be on this thing. And I want the radius of this to be 3. 3. And I can see I have one other problem here, which is that I want this point and this line to be intersecting with each other, piercing with each other. Now that is fully defined. All right, so now I'm going to take this sketch 2. I'm going to take both of these sketches, and I'm going to do a sweep. So it's decided which one is the path, and that is great. That is what I want. All right, so that's that piece. I think what I need to do now, what I want to do now is this other arc that is defined by these lines. And to do that, I need to offset this plane or make a reference plane that is some distance away from this, 1.15. And I want to go the other direction. Yeah, that's going to help me if I do that. Now on this plane, I want to make a sketch. I want to look at that sketch and I want to convert entities. I want this and this and this and this. Convert those entities. Now I'm going to trim that. That's what I want. That's done. I'm going to take that thing and make an extruded boss base the other direction. And that is going to be 1 inch according to section AA. Okay, so this is fantastic. I have created 2 main parts of this hub. Now, let's go get this little foot that's way over here. And to do that, I need to draw another cross section that is offset from this plane a small amount, 1/4 of an inch. So I'm going to make a new plane offset from this one, 0.25. That's what the drawing says. And I want to flip the offset because it needs to go down. Great. Now on this thing, I need to make a new sketch. Okay, and how's that work? It's going to be right in this area. Okay. I could flip this around and look at the other side, which might be more helpful. Yeah, it's right down in this area. Convert entities. Let's take that. Because that one, I'm pretty sure, is the same. Then I have something going on like this. I'm not entirely sure. I don't think I made those coincident with each other. There we go. Let's go fix that. Oops. Okay. Yeah, and then I'm going to have that arc. This is what I was trying to do a few minutes ago, which was not the right cross section. Okay, so first of all, I want the center of this and this to be coincident. I want this thing and this thing to be equal to each other. I want the distance from this point to this point to be 0.93. And I want this arc to be 3. Okay. Now I don't know why it's taken my relationship off again, but I'll go fix that. No big deal. This one should be coincident. And it didn't like some of this. So what does it not like? I don't know what it's doing with this. First of all, let's delete this. Okay, let's go put in the other dimension that's missing off of this, which is that the distance from here to here needs to be 1.3. Okay, we have a problem, obviously. Let's delete some of these. Not sure which one is causing that problem. Okay, look, here's the center of this circle. We want the center of this circle to be on this line. Whoops. Okay, this thing and this thing to be on this line. Something has happened with a lot of things here. Delete this. Okay. I don't know what's going on with this one. That one seems to be causing a little bit of trouble. Okay. Now let's get our dimension from here to here. 1.3. All right. Then what I want to do is get this and this to be coincident, which it does not want to do for some reason. It does not want to do that. Okay, I'm just not really sure what I've messed up on this. So I'm just going to delete some of these and try that again. All right, let's get a line from here. Oops. Let's get a line from here to here. All right. Then let's get a dimension from here to here. Okay, and what is this wanting to do? Okay, let's delete this one. Smart dimension. I'm not sure what ones these are. Okay, look, I have spent too much time messing with that. Let's see if we can get these ones in the right position. Okay, this one is 0.93. Okay, let's see if I can just keep going around like this. 0.93. And then I've got an arc that goes from here to here. And I need this arc. It's interesting. Do I want the center? I need this arc and this to be coincident. Why is that doing that? I think I can come in here and delete one of these. What happens if I make these equal to each other? What happens if I make this where I want it to be? Something is freaky on this, obviously. Just delete that. And delete that. Okay. Item unresolved. Oh my goodness, why is it taking me so long to fix this stupid thing? Okay, let's actually just see what this dimension is right here. Okay, that's 0.93. And if I dimension this, this is what I seem to be getting trouble with. Oops. Okay, I'm going to leave it as a driven dimension. That's supposed to be 3, and it is 3. This is supposed to be 0.93, and it is. I don't seem to have this dimension right here, which is specified in the drawing. And this one, I want to let this one drive. Can I do that? Okay, I don't know what's gone on with that. Just disregard all of that. Let's make a new sketch on this plane. Okay, I can't spend too much more time messing with this. Let's try it just to think about it differently from this area up here. Let's draw a line from there to there. Great. Let's draw another line from here to somewhere. Let's dimension this distance from here to here as 0.93. And then let's dimension this as 1.3 divided by 2. Oops. All right. Then let's take this one. Whoops. And let's just mirror this thing. Mirror it. And let's mirror about this. And just take it that way. Then let's put this arc on here. And then let's dimension this thing to be 3. Okay, so then I got that. So I got the 0.93, got the 1.3, and I got the other one. So it's fully defined. I don't know why I couldn't make that happen before. And as you can see, I've unfortunately done that on the wrong plane, but that's okay. I can come into my sketch and I can edit the sketch plane. I can go pick this one, and that will just move it down. Okay, great. So that's that. I'm going to stop worrying about why I thought it worked or why it didn't work. I'm going to do a lofted boss base from here to here. We can see that's all kind of twisted up. We don't want it to be twisted up. We're just going to leave that there. Hold on, come back. I'm going to move these endpoints. And that's what I want right there. Wow, okay, that was not easy. I don't know what was going on with my sketch, but you know, we stuck with it. We tried to keep our cool. We tried things in slightly different ways. Let's turn those off. Okay, now we just have like this massive loft that has to happen there. I'm just gonna check this just because. I should have a fairly smooth transition across these faces, and it looks like there is. For the most part. Okay, well, we're just going to go for that, and then we'll check our mass, and we'll see what we get. All right, now what I want to do is I want to create a loft from this face to this face. Features, lofted boss base, from this face to this face. Okay, that's looking about right. I want to do the start and end constraints so that they are tangent to the face. Perfect. And I want to change the start tangent length to be 1.8. That's what the drawing note says. And then I want to do my end constraints tangent to face as well. And I want to make that 1.8. And we are done with that. Let's check the evaluate. Zebra stripes. I think that's pretty good. Okay, we're going to check our mass. That's going to be the telltale sign on how we're doing here. Okay, measure, evaluate, mass properties. 1.9 pounds, and the drawing says 1.9 pounds. Excellent. So we're going to be done with this. I'm going to put this into the assembly now. Just because. So that's the end of the spoke. Let me turn off the zebra stripes. I am now going to put this, and I'm actually just going to make the wheel. I'm not going to make the assembly yet. I'm going to now make the wheel. So we are about an hour into this test at this point. Now we're going to create a new part. The new part we're going to create is the wheel. Not the wheel, it's called the tread. File, save as tread. We're going to go into the proper units, IPS. We're going to go into our material and edit this. And the drawing says that we are 5052H32. Okay, 5050, that is an aluminum. 5052H32. 5052 H32. Apply and close. Okay, great. I'm going to make a wheel. It's going to be a revolved thing. So let me just, whenever I make a revolve, I'm always starting with an axis, if I can, which I always can. So I'm going to draw on the top plane and then revolve around this axis. So let's go ahead and do that now. Okay. Okay, in essence, what's going on is that I have a line somewhere, like this. And then I have, okay, let's just start getting what we know. So from here to here is half of 19.2. 19.2 divided by 2. Okay. Now I prefer to see this thing while I'm over here, so let me, well, that's not what I wanted. I prefer to see this, so let me drag this over here. Okay, let's see. Just got people contacting me. Okay, and then frankly, I want to have the center of this be lined up with the center of this. Okay, so that's that. And then, whoops. Going back over to our sketch, which I accidentally jumped out of. I'm going to dimension this. This one is going to be 9.2. Okay. Now I need to just keep figuring out how I'm going to do this. Okay, so on one side of this, I'm going to have something that's like this. And from here to here is 0.5. And this is 0.5. And I'm going to trim this. Boop. Oops, and I got to get one other dimension. Good thing it's blue. It's helping me see I got more to do. That one's also 0.5, so we have a little 0.5 thing there. Let's take these features and mirror them. Okay, these ones, let's see, get out of the sketching. Let's take those ones and mirror them around this. Great. I'm going to come in here and trim this. Great. Okay. So that is the bottom of that. Okay, then 3/4 of an inch away, I've got another line. Whoops, get out of there. I've got another line, and it's vertical. And this one, the distance between these ones are 0.75. Okay. And then I have some sort of arc that's in here. I'm going to do that with a circle. Okay, so my center of my circle, I want it to be aligned with this. And I want it to go over to there. And this circle is going to be whatever that dimension was, which is 40.5 for the radius, but that's 2, so that's 81. Okay, there we go. Great. Now what I want to do is get a vertical line, a horizontal line like this, and another horizontal line like this, and go in here and trim this, and I should be in pretty good shape. Okay, we need to trim over here. Great. Now I'm going to take this dangling line and turn it into a construction line. It was what was helping me get the apex of that. Okay, great. Now where have we messed up on this? We have messed up in the sense that we need to place this here. So we originally had centered this line, but then I cut the line, and that is, this is the right number, but I'm just going to make sure by doing that. And we are fully defined. So I had originally placed this 9.2 length line centered on this, but then I split it with some cuts and some other stuff, so it's lost that relationship. Great, so here's my sketch. I'm then gonna take that and do a revolved boss base. And I don't wanna use this, clear this thing. I want my axis of revolution to be this one. Great. Okay, so we're on track here. Save this thing. Okay, now we got to get the tread on here. And the tread is, according to the drawing, going to be a 1/2 inch away from this surface. And then it's going to be sort of this S-curve. So in order to know where 1/2 inch away is from this surface, I'm going to do a surface offset. And I'm going to switch this to 0.5. And I'm going to go in that direction that we're seeing right now. That's great. Good. So what I'm going to try to do is put a tread right in between this surface and the outside of this hub. What I need to do is draw the shape for that. And the way I'm going to do that is I'm going to create a new plane that's right up in this area. So let's select this. And then let's make a reference plane. Okay. I'm going to draw a plane to see if I can get right in between these. Okay, that was good. Go back. I'm going to draw on this plane that's right in here and then extrude it down and extrude it up to surface. There's probably many ways to do this, but that's how I'm going to approach it. Okay. Now what we need to do is get this tread dimension, this tread thing on here. Okay, so one of the things we know with this tread is that I have a horizontal line and a horizontal line. Okay, and I got another one of these. It's somewhere right over here. And frankly, I'm going to just deal with what I know at this point, 0.25. Okay, and I want this one and this one to be not that. Okay, I want this one and this one to be the same. All right. And then the distance between this point and this point is 1.5. But I'm going to center it all around this plane, so I'm just going to go over to this one. So 1.5, so 0.75. And then I'm going to do the same thing for this one, 0.75. Then I want to get from here to here. This is 0.18. This is actually one of the reasons why I didn't put the fillets on the edge, is because I just don't want to have to be picking fillet edges right now. Okay, cancel. That's not what I wanted. From here to here, 0.18. Okay, great. Those are in the place that they need to be now. And now I need sort of an S to go between these. If it be possible, I want to do this with arcs and not splines, because splines have their way of getting pretty messy. Okay, let's see. Somewhere around here, we're going to have something like that. And then over here, we're going to have something like that. And then, frankly, we're going to have the same exact thing. And another one. here to here. Okay, let's see if we can get some of this cleaned up now. We want this and this to be tangent to each other. And we want this and this to be tangent to each other. Okay. And then let's draw a construction line between these two dots. Because I want the center of this. Okay, so we're done with that line. I want the center of this line to be lined up with the center of this. Okay. I think that's good. Now let's get some dimensions on this stuff. Okay, let's see. Actually, when I look at the curve, okay. This curve and this curve are going to be equal to each other. And this curve are going to be equal to each other. And I'm going to dimension one of them, 12.93. And then I'm going to dimension the other one, which is going to be 13.18. I got to look at it this way. My brain wants to look at it this way. Okay, one other thing that we got to do, I think, we took the center of this little line and we aligned it with this. We need to get its other center and, and align it with this one. So where is that? That, I don't know if that's going to work. Let's try it. Okay. First of all, I want to align this and, okay, I can only barely see this the way that I want to. Let's see if we can do this. The center of that and this it's looking slightly funny to me. So I'm going to go back to our, whoops. I'm going to go back to the view, this view. Seems like we should have a constant kind of thickness everywhere here, and it looks like it's getting thinner in this. So that's troubling me. Maybe one way to deal with that is to make this thing horizontal and okay, well look, it doesn't look so funny anymore. Okay, so that's looking good. What I'm slightly confused about, let's save this. I don't want to lose what I just had. So even though it's underdefined, I'm going to save it. Now I'm going to edit this sketch. Let's go find out where we are. Okay, there we are. Trying to find out where we are unconstrained. Okay, yep. So what we need to do is take that little line that we just had, and let's try to add in this relationship again. There we go. We've turned all black now, so we are defined. I'm going to take that as good for now. See if I can finish these operations. So I put that little sketch right in there, and we're going to create a boss base, extruded boss base. Okay, and the thing that I want is that sketch that we just did. And I want to go up to surface. Go up to that surface. Do I need to flip that? Yes. Okay, and then my other direction, I want to also go up to surface. To that surface. Excellent. Okay, then we're going to take this thing and hide it. Now, if we had a really intense pattern, which it might be that what's going to be created here is an intense pattern, but if we had a really intense pattern, we would wait to do the pattern until after we do the rest of the garbage that needs to be done, but I'm going to just try it right now anyway. Okay, the features that I want to pattern are this one. Okay, and the direction that I want to do this in, okay, is that axis. I don't want 6, I want 48. It's thinking. Okay, great. So now looking at the drawing, we've got a couple more things we need to do. Let's add in a fillet into here and into there. And on the other side, here and here. Okay, great. Now let's get our chamfer in there. Chamfer. This chamfer is shown in detail B, which is 0.1, which is what we've got. Okay, great. That's what we want. Okay, that is actually the part. I think we're done with this part. Let's save this. What was requested for this particular part to be turned in? Oh yeah, we need a screenshot in isometric view. Essentially in that view. So that would be our screenshot. Okay, we have saved that. Now let's go into our assembly. Assembly. Let's get out of our exploded view, which we don't want anymore to be looking at. And let's go get the spoke in there. Insert component, existing part, spoke. Okay, great. We want this face and this face to be mated to each other. Excellent. Let's take that line. That line and mate it to each other. What's happened? What's happened? What's happened? We want to reverse that one. Okay, where's our mates? Flip mate direction. There we go. All right, now I'm going to take this curve and frankly anything else on here, like this one, and make it concentric. Okay. I don't know exactly what I did there. This mate is over-defining the assembly. This mate is having a problem. Let's delete that one. Why is that mate having a problem? Okay, well, nevertheless, I have a spoke that is not constrained in one of these areas. So let's just take this point and make it coincident with this line somewhere. Except that's not really what I wanted to do, so that was dumb. Okay, let's delete that one. Yes, delete that. Okay, is it possible for me to take this line and make it aligned with this line? Cancel. Okay, people, why am I having trouble with this? Okay, maybe what we want to do is just get this line that's here and this line that's here to be parallel to each other. That looks like it might have worked. Okay, we're going to take that. File, save that, save. Now I'm going to take this spoke and I want to do an assembly pattern, circular pattern. And I want to have 6 of these. And the direction that I want is this direction here. I could have chosen an axis, but I was being slightly lazy there. Okay, great. Save that. Now let's get our wheel in here. Insert component. We're about an hour and 10 minutes or so, an hour and 15 minutes or so into this test. Tread. Okay. We need to turn on our axes here. Or excuse me, our planes. Wow, that's super mess. Let's not do that. Let's see instead if we can get, okay, just this thing and this thing to be concentric. Okay, that's good. Then let's get this surface and this surface to be coincident. All right, now this thing can still spin around. I guess if I was a good citizen, which I should be, I'm going to take this concentricity and I'm going to lock it. Okay, that should mean that I can't move that one anymore, which I cannot. Okay, so what do we have here? That's not the side I wanted to look at, but while I'm looking at it, that's a good thing to look at. This is the part. Okay, so this would be a screenshot that I'd be turning in. Okay, I should probably have checked the mass of the wheel, which I did not do. That would have been a good thing for me to do. 83.65. Tread, excuse me, that's the tread. Nope, that was the whole assembly. I'm gonna go find the tread. The tread should be 44.88. Evaluate mass properties, 44.61. That's close. I'm gonna just take that. Okay, what else do I need to do here? This is okay, I need to do an interference check. Okay, with the assembly, coming into the assembly, let's save the assembly. The assignment says, the test says to do an assembly interference on the D3.5 state. So going into my assembly up here, I'm going to switch to the D3.5. And I'm going to save that, and I'm going to rebuild that. Sort of strange, I can see some little ghosting features in there. Let's look at a cross-section of this just to see how we're doing. See, this is weird. This should be expanding out, but it's not for some reason. Let's edit this, go back to the 2.5. Okay, look, so that's That's done something that looks proper. Let's go to our 3. Just thinking, calculating, looking at all of the features and such. Sometimes what you got to do is just got to get this thing to... Okay, it did not want to deal with that one correctly. I'm not sure why. Okay, so again, like I'm saying, with master modeling, you're linking a bunch of files together. So I don't know. Let's just close this assembly. And let's make sure I don't have any of these are open. Tread is open but saved. Hub is saved. Shaft supplied. Just close that one. Now we're going to come back in here and open up our assembly again. Look at our cross section. Okay, some weird things going on in there. Oh, this because I'm not looking at a cross section right through the middle of it. But I can see that I'm not mating the way that I should be. Why is that the case? That's super weird. That's super weird because we don't have any shaft that's that size. Oh, it's because we're not looking in the middle. Let's go back to this for a minute. I'm going to look exactly in the middle or close to it. Say about right there. Okay, that one seems to be right. Okay, there we go. 3.5 is now correct. Not sure what it was doing, but now I am confident that we are looking at the 3.5. What we need to do now is an interference analysis. Evaluate, interference detection, calculate. Well, that's calculating because it will take a second. I'm going to go see what else I need to do here. Okay, I got my 3 screenshots. I did not get my 3 screenshots of my spoke, which I'll need to do. That should be easy. I got my screenshot of my tread. I've applied the decal. I've assembled the wheel. I'm checking for interferences now. Then I need to calculate the limits of size. So this is going to cause me to need to open the book, the guidebook, which I will do now. Going to the guidebook, still calculating interferences. This is good. I got some stuff working in parallel. Okay, so it found 6 interferences. These are small. These are super small, but they are nevertheless interferences. And so I need to understand what they are, where they're coming from. Okay, it's between the spoke and the hub. Okay, luckily all those interferences are the same. So I'm just going to write down right now that I am 7 times 10 to the -5th inches cubed. Okay. And that's between each of the 6 hubs. Excuse me, each of the 6 spokes and the hub. Okay, well that's great. Save this thing. Okay, so what I'm going to do now is go to the chapter in the book that talked about interferences, or what do we want to call them, clearances and mechanical fits and stuff like that. Okay, that's in chapter 8, mechanical fits. And I need to read this. Choose a fit class where the accuracy of location is of prime importance. Okay. So that's not a running and sliding fit. It's not a running clearance. Okay. LN1, let's take this one for a second. LN1 from table 8.4, where accuracy of location is of prime importance, and for parts requiring rigidity and alignment, but with no requirement regarding force transmission. Okay, LN1 sounds good. I'm going to find the LN1 table. Locational interference, LN1. Here we go. And if I go back to the assignment itself, it has a nominal value in here. Nominal value of 2.5 inches. Probably the easiest way for me to do this is to 2.50 is to use the worksheet. I'm going to write down the information that's needed for that. Okay, LN1. Okay, we're going to have 0.1 and 1.3 and plus 0.7 and 0. I got to get these numbers right. If I don't get these numbers right, the whole thing's wrong. So I'm going to double check it now. This one's for the shaft, this one's for the hole, and this one's interference. Okay, so 2.5 is my nominal. So I'm in the right area, and I got 0.1 and 1.3, and plus 0.7 and 0, and 1.3 and 0.8. Okay, so I'm going to use the worksheet that's here. Okay, I want the LN1. Okay, maybe what I'm going to do is pull this over to my iPad so you can see what I'm doing. So let's download this. Fit into my downloads. I'm going to take this, send it over to my iPad. Okay. Okay, so this is for interference between the hub and the shaft. Okay. We had already decided that we want to be an LN1, which is what we're going to go for. The nominal size here is 2.5 inches. So my nominal size is 2.50. I already went to the table and found out the stuff that I needed which is here. Okay, and the clearance or interference is 0.1, and this is all thousandths of an inch. So it's like this, or 0.0013. And then I got 0.0007. There's a plus on that one. And then I have 0. And then I have 0.0013 and 0.0008. Okay, so I have got an interference fit. Because I have an interference fit, I want to use this one. And so my nominal is going to be 2.5 plus H1, which is that 0.0007. Okay, so that's pretty clearly 2.5007. And then I got my nominal value, which is 2.5000. And then I've got the diameter of my shaft is going to be my nominal value, 2.5, plus S1, 0.0013, 2.5013. And then my next one is 2.5 plus 0.0008, which is clearly 2.5008. Okay, those are my four numbers. Those are my four numbers. And so for the shaft itself, which is a hole, the shaft is the part that is the hole. So the shaft upper value is going to be 2.5007, and its lower value is going to be 2.5000. And then for my shaft size is going to be 2.5013 and 2.5008. Now, we were looking for an interference because LN1 is an interference that is not meant to transmit forces, but is meant to have excellent alignment of parts. And so we should see that there is a minimum gap, that's this one, a minimum gap of 0.001, which is what we have. And then we have a maximum gap of, let's see, the maximum gap would be when the shaft is the smallest, and the hole is the smallest, and the shaft is the largest. That's going to be 1.3 thousandths of an inch. And those are the numbers that we have right there. So these are the correct numbers that should be uploaded. All right, so we are now about an hour and a half into the exam, and we have essentially finished everything. Let's just do a double check on this. Okay, we have made the hub, and we have got 3 screenshots. We have made the wheel spoke, and we need the 3 screenshots for that. And so the way we would get that is pretty easy. Just come into our spoke part, which is this one. And then we need a view that is, let's see, what is our right views? We need these kinds of views. So let's see what this one is. This is one of our screenshots. And then we need the side version of that. And this is one of our screenshots. And then we need the top version of that. And that is our other screenshot. So those are our 3 screenshots that we needed for that. Okay, the next one then is to model the tread. And we did model the tread. And we got our screenshot, so we're good with that. Then the next problem was to make the assembly, which we did. Add the decal, which we did. and then take a screenshot, which we did, and do the interference, which we did. And then the last one was to calculate the limits of size, which we did, and then report those numbers, which we did. So we are done. The last thing we would need to do would be to just come in here into our assembly and get a full and final pack and go on this. When doing the pack and go, we don't have any drawings. Include toolbox, cable, blah, blah, blah. Include custom graphics. Okay, and I'm going to come over here and export it as this. All right, so that is that. I know it's a challenging exam. It gave you opportunity in many ways to show where you had strength, where you had some weaknesses. It also gave you the opportunity to take this complex product, kind of break it down into simpler pieces. And you could at least see how I went about doing that. And hopefully that will help you if you were wanting to compare to how you did, or if you're not quite sure how to do it at all, or if you wanted to go back and do this so that this Mars rover wheel becomes part of your portfolio. All right, thanks everyone.